All right, good morning, everyone. We're happy to be here. We are joining you from a company called Tredence, which is a data and analytics company focused on empowering our clients with industry-specific data science solutions while also bridging the gap between insights delivery and value realization through enabling last-mile adoption. A little bit about myself. I began my career in inventory management at a mass retailer in North America. So fresh out of college at the age of 22, on my first day of work, they put me in charge of $200 million of annual receipts. I was in charge of forecasting the product, ordering it, tracking purchase orders, and then allocating it across thousands of stores within North America. Needless to say, first job, 22 years old, zero experience, mistakes were made. Me and my peers would often joke about the fact that we were making million-dollar mistakes left and right. Not that that's a laughing matter, but it was happening. In fact, I remember one of my peers accidentally sent a 5-year supply of toaster ovens to the island of Hawaii. In order to resolve that, the retailer had two options. They could either clearance out the product, salvage it, donate it, get rid of it and get it off the books and place a new purchase order for that inventory, or they could send it back to the continent. That was the option they chose. So they put all those toaster ovens back into a ship, and they sent it out across the Pacific Ocean. And it took about 6 weeks for that inventory to land back in California and for it to get sent out to the various stores in North America. Not only was that a costly mistake from a supply chain perspective, but it also cost the retailer and the CPG company 6 weeks of potential sales due to the out of stocks in the stores that were supposed to be selling the product. So customers were walking into the stores, they were going there to buy their toaster ovens, as customers are apt to do, and they were faced with empty shelves. So on-shelf availability is near and dear to my heart after those types of experiences, and I'm happy to be presenting today on one of Tredence's solutions in that space. All right, so getting into industry challenges right now. So some of the challenges we're seeing within the CPG and retail industry include the supply chain. I think we've all heard about how that has been very disrupted, in large part due to the COVID pandemic. Ports are being shut down in China, they're being delayed in LA, and product is flowing through the supply chain a lot more slowly. And that's resulting in a lot longer lead time to get products onto the shelf. In addition, it's becoming a lot more costly to ship. So last year at this time, it was costing about $5,700 to ship a container from China to the US. This year, that number is $16,000. So CPG companies are having to mitigate that type of cost increase in their supply chain and frequently are having to take some price increases. Another thing driving those price increases is the rise in inflation. So CPG companies are being given cost increases by their suppliers, and they're having to determine whether or not they can pass those cost increases along to their customers. And if so, what type of impact on the demand is that going to have? Another large challenge in the industry is managing the consumer and their behavior and how that's changing and adapting with time. One of the things we're seeing is the customers are shifting into the e-commerce channel because they value their time and convenience. They're shifting into club because they value value. And they're wholeheartedly embracing private label in a way that they hadn't before. So private label is becoming a viable competitor in this space. All of these factors can influence, again, how quickly product can get to the shelf, whether it's getting to the shelf, and what demand will look like once it is in the stores. In terms of some of the out-of-stock problems, retailers are facing about a $1 trillion loss in retail sales caused by out-of-stocks. 7.4% of CPG sales will go unrealized this year due to the out-of-stock issue. And about 32% of shoppers will walk into a store and they will find empty shelves when they get there. In addition, to make matters more complicated, 18% of shoppers will walk into a store with an advertisement in hand, expecting to pay $9.99 for a product. And when they get there, the shelf price will be $12.99. And they will have to make a decision saying, will I buy that product or not? And CPG companies are having to take into account that level of volatility in terms of their demand forecasting and how the customer will respond. In terms of the current approach that CPG companies are taking, we really believe that it's limiting their success, it's limiting their actionability. Their insights are aggregated, and what CPG companies really need to solve a problem like OSA, or frequent out of stocks, is granular information at the store and product level. They're having a lot of challenges operationalizing. So if you think about a CPG company, they're procuring raw goods, they're producing final goods and materials, and then they're also forecasting as well. And their production teams and their forecasting teams aren't necessarily talking. So you might have a forecasting team who says, hey, this week we're going to sell 1,000 units, or a little bit in the future, we're going to sell 1,000 units. And the production teams are like, great, we're going to produce 600 units. And then what does that cause? A delta of 400 units, and that's going to create, again, an out of stock on the shelf. So there needs to be greater levels of visibility and communication within the supply chain visibility for the company. Additionally, forecasting is really done with their eye on the rearview mirror. What has happened historically? This time last year, how many units were we selling? And while that is an important data point, one might say the most critical, it can't be the only one. We've seen the level of volatility in the industry and all of the different challenges that CPG companies are facing, and more variables have to be taken into account in addition to history. And all of this is resulting in a lack of speed and robustness. Oops. So we believe that CPG companies, in order to succeed in this environment, really need an end-to-end transformation. They need to dig into their supply chain and create more visibility in what's going on. They need to have visibility into how their demand forecasts can align with their production schedules and their procurement of raw goods. They need to have an understanding of what is in their warehouse right now and what is available to be shipped the next day. From there, they need to improve their forecasting processes to be more comprehensive of all the variables that impact demand. And they need to execute precisely. So I mentioned that advertised pricing is not always showing up in stores. So how can you control that what you're expecting to see happen in the market actually does through better store training or your merchandisers training? And then when it comes down to in-store execution as well, how can you ensure that the products are being pulled from the back room to the shelf? Because that's another problem they have. They ship the items to the stores and then they sit in the back room and need to get brought out to the sales floor to actually be sold. So I talked a little bit about the current state, but a few additional data points that are happening within the CPG industry. I would say at this point in time, CPG companies are pretty good at knowing what's out of stock right now. And they're even pretty good at understanding what might fall out of stock within 2 weeks' time. However, given the volatility of the supply chain and the length of time it takes to procure and produce and ship goods and actually get them through that supply chain, 2 weeks is pretty inadequate to address the problem and get ahead of it. So we believe that there are additional steps that need to be taken in order to succeed in this environment. And that includes something like classifying out of stocks, identifying a root cause, and then creating strategies to address those problems moving forward. So to take a specific example, so I mentioned that history is not the only data point, but it's an important one. So where we start is taking all of the historical information on out of stocks that a company has. And from there we can identify, hey, was this a sporadic out of stock, just a one-time fluke error, or is it a chronic out of stock? So in theory, an item might be falling out of stock like clockwork every 5 weeks. And then the system can start to identify what is the process that's happening that is causing that chronic out of stock. And it might identify that on the 4th week of the month, there's a promotion. And so what might be happening is that the demand forecast for the promotion is inadequate to support demand. And so an order needs to flow in right at the end of the promotion to backfill the inventory that was sold. Another recommendation that might be given is there's not enough shelf space on the floor to support the demand that the promotion is generating. And so we need to partner with the retailers to secure incremental space in the store so that when customers come in, the inventory hasn't flown off the shelf, it's duly located so that they can find it somewhere else in the store. And then this algorithm will identify that root cause, and it'll identify what are the right actions to take. And the beautiful thing about the ML algorithm is even if it's not the perfect solution at the time, you can provide that feedback to the algorithm, and then it learns for next time. And so it creates this feedback loop where it just gets smarter and smarter, and then can make better recommendations moving forward. In terms of a couple success stories amongst our customers, so we've worked with a couple CPG companies, Fortune 500 companies, on this type of solution. The first company, we had pretty good visibility into their supply chain, as well as the retailer's supply chain. So what we were able to do was create an ML-based automated system that would generate alerts for merchandisers in stores that identified phantom inventory. So phantom inventory, for those who aren't familiar with the industry or the concept, phantom inventory occurs when a retailer's system believes that there are units on hand, but there actually aren't. And that can be driven by something like theft. So someone comes in, they walk out with an item without paying for it, so it doesn't get systematically updated in the system, or possibly breakage. A sales rep might break the item and then throw it away, and then, again, not want to write it off. And so when you have that type of situation, then this algorithm can identify which stores are at risk or which items are at risk of being phantom inventory, so to speak. And through implementing this and generating those smart alerts, we were able to generate a 9% lift in revenue for the company. Another example was an area where we did not have great visibility into the supply chain. We had distributor invoices and we had retailer POS data. And through bringing those items together, as well as generating a couple other insights and applying the algorithm and analytics, we were able to increase on-shelf availability by generating automatic store replenishment alerts. So an order needs to be placed because this item is at risk of falling out of stock. And when creating those smart alerts, we were able to increase distributor invoices by 13%, and we saw a 22% increase in OSA in-store as well. I'm going to hand it over to Sunil, and he's going to talk through the technical aspect of how we went through this.
All right. Thanks, Annie. So before I start, what I'd like to say is, while we've implemented the OSA solution for a few customers, what we've also done is we've taken a look at all of the solutions that we've built across all of our customers, and we've tried to put them together in a sort of an accelerator. And what is an accelerator? An accelerator is sort of the building blocks of a solution that you can take and you can implement in another new customer, and then you can start customizing it, integrating it, and then going in from there. Is it a pure play product? No, but it does accelerate your time to value. So if you take the OSA solution to your customers or to your company and you set it up, rather than starting from zero, you're starting from 50, 60%, and then that's where your time to value comes into play, correct? So let's quickly get into what our OSA Accelerator is all about. Starting with, let's look at the data that we read in, right? Annie spoke about that. Definitely POS sales data is something that we need. And the way we look at POS sales data is at a location for every SKU at a daily basis. So basically, it's location SKU day and how many sales per each unit for that particular store. We also get, depending on the type of customer that we have, right? We also get inventory on hand at every store for that unit for a day. And that's really useful in calculating certain types of alerts that I'll walk you through in the next couple of slides. But we do get on-hand inventory available within the stores, and that's reported on-hand availability of each of the SKUs. We also get replenishment data, right? And replenishment data can be two types. It gives you DC replenishment, and it gives you in-store replenishment, correct? And it is, again, at a store SKU level or it's at a DC level. But what this also gives you, it gives you lead time. It gives you how much time does it take for it to come from once the order is placed to the DC, or once the order is placed in the store, how long does it take from the DC to the store. So that also allows us to calculate safety stock and make sure that we're having enough stock in the stores available. If not, we can raise an alert, and that's another type of alert that we've had. We also get promotion data. Annie spoke about it. We want to know what items are on promotion so that we can expect a spike in sales, adjust our demand forecasting algorithms so that we know that this item's on sale, there's going to be high demand, and accordingly adjust for that. And finally, audit and store masters are data that we get, but that we account for in our solutions as well. The next part of our accelerator solution is we've built out standard ingestion pipelines to ingest all of this data into our system, and I'll talk about the architecture in some time, but we've got standardized ingestion pipelines. We know what this data looks like, we know what attributes are needed, and we know how to pull this and ingest this, and we've got ready-made notebooks and ADF pipelines for that. We clean and prep the data. When we clean and prep the data, what do? There's a lot of missing inventory values for some of the stores, for some of the inventory SKU items in the store. So we try and immute those values based on previous day values and fill it in. So we're not dealing with missing values in that case. The next thing that we have are a set of alerts that we set up. I'll walk you through in the next slide over what these alerts do and how they're set up. And then lastly, we also have a front-end web app. And this web app is typically used by your category manager in the CPGs, and he is responsible for making sure that your SKUs don't go out of stock in your stores, right? So he's able to get these alerts. He's able to see what items are on out of stock or what items are not available on shelves and take appropriate actions accordingly. Moving on. So Annie spoke about, understanding why a particular item goes out of stock. And we've classified out of stock into 3 or 4 types of out of stock solutions. The number one, as she spoke about, is phantom inventory, right? Now, how do we look at phantom inventory? We look at phantom inventory as the difference between the inventory on hand that the store is supposed to have versus the inventory that is actually available within the store. And that's how we get phantom inventory. And in the next slide, we'll also show how we account for those alerts. Typically, when we have phantom inventory, we want to make sure phantom inventory is restricted to about 3 to 4 times daily sales so that we know that we are able to take care of phantom inventory and not account for a loss of sales because of that. The next one is safety stock. Now, let's assume that we've got an average daily sales for a particular product at 10 units per day. And if we place an order for replenishment for that particular product, it takes us, say, 10 days to get the product back replenished in the store. So the safety stock would typically be 100 units. So we need to make sure that we're maintaining at least 100 units within the store so that by the time that we send the order for replenishment, we get it back in time and we're able to not miss any sales. Zero sales events is another type of alert. Now, not every zero sale day for a particular product is an alert. I mean, there may be very legitimate cases where there was no demand for that particular SKU in that store. But how do we identify that zero sale day was because of the product not available on the shelf? And the way we do that is we look at the probability of the SKU not being sold for that particular day, and we keep compounding that. So as and when we compound that, let's say we have probability of a product not being sold on day 1, compounded with the probability of product not being sold on day 2, day 3, day 4, and as and when the days get compounded, your probability reduces. And when it reduces beyond a certain threshold, that's where you have your alert kick in. And lastly, you have your off sales, and which is where your true on-shelf availability alerts come in, right? That's where we look at how your demand is being forecasted versus how your actual sales are happening. And if there is a major difference between your projected demand versus your actual sales, that's where it triggers an alert. But again, here we have, you can't just trigger it every time there's a difference. So the way we look at it is if there is a continuous difference in demand versus actual sales, and that difference is greater than, say, a threshold of, say, 15 to 20%, and that persists over the next 3 to 4 to 5 days, that's when we realize there's something off, and then we can trigger those alerts. Yeah, and when we look at phantom inventory, the way we look at this is we calculate it at every store, at every product, and we do that using the difference between actual on-hand inventory and the estimated on-hand inventory. And if you look at the graph here, right, the green bars show the days when the stock is being replenished, right? And the blue items show the actual available on-hand inventory. And the gray line is your sales. So if you look at this, the way the sales are increasing, your inventory is coming down. And at a certain point in time, it seems like you do have some kind of inventory available, but your sales are dropping off. And until your inventory is replenished, your sales kick off again. That shows that inventory that's available with you is phantom inventory. And that's why we really need to track that phantom inventory to make sure that you're not having inventory which is damaged or which is not available to the customer, but you're able to make decisions and order replenishment accordingly. Similarly, for zero sales, like I spoke about earlier, we look at the probability of a zero sale event and compound that, and when we look at it across multiple days, and the threshold is breached, that's when we trigger a replenishment for zero sales. And similarly, once we do this, we then run our demand forecasting algorithm, right? Our demand forecasting algorithm is typically an FB profit algorithm, and we've got regressors. And what are these regressors? These regressors are all of these out-of-stock alerts. Now, when you use these out-of-stock alerts and you improve your demand forecasting algorithm, you now have a very, very clear idea of what your demand is going to be and what your actual sales are. And like I said, when that difference is consistently greater and it goes on continuously over a period of days, that's when we trigger your on-shelf availability alerts. Lastly, I'll come down to our technical architecture. We've built this on Azure Databricks, and we've got ADF pipelines that we've captured all of our sources, and then we load them into our Delta Lake. Once we've got that in Delta Lake, we've got two options. We've either got ADF pipelines to transform clean prep data and load it, or we use Databricks notebooks as well. Some of the clients have gone with ADF pipelines because it saves them cost. Some of the clients have said, no, they'd like to go Databricks, and then they go with Databricks as well. We then have our demand forecasting algorithms running in PySpark, which calculate demand at a location skew and a daily level. And the way we've set these up is these are all parameterized, so you can look at a 3-week demand forecast, you can look at 12-week demand forecast, you can look at a 52-week demand forecast. So that's purely customizable, and then the way we've set it up is as long as you set the parameters right, you could look at what your demand forecast is going to be. Last and most important thing is once all of the demand forecasts are set and you're able to calculate all of those alerts, they're pushed into a SQL Server database, which is then visualized through either a web app or a dashboard to make it actionable to your category managers. And that's where the power of the solution lies, because they're able to look at these alerts on a day-to-day basis or on a real-time basis, and then accordingly make decisions as to whether they need to order replenishments or not. With that, I think we've come to the end of our presentation, and probably take 10 minutes for questions.
Yes, so any questions? Any questions?
I have a question about the feedback.
Sure. So the feedback from the stores comes in terms of the phantom inventory alerts, right? So the phantom inventory alerts go out, and we are not sure whether it's truly phantom inventory or whether it's that we're calculating incorrectly. When we get that feedback from the customers there, that's when we tweak back the algorithms.
Okay, and use the client.
Yes.
Any other questions?
Question is more around the implementation of what's the timeline for implementing something like this?
So typically when we've done it from scratch, when we did it from the start, we did it for our customers, it took about 6 to 9 months. But with this accelerator, when we've now gone to newer customers, it's cut down by half. It literally comes down to about 3 months down. Because you've already set up most of the difficult part is already done. You've got your data model, you've got your pre-built pipelines, you've got a sample notebook, and you've got demand forecasting algorithms already available. So what you now need to do is make it more real for that particular client and look at what nuances are there for that particular customer, how they look at categories, and then tune it a little bit and to improve your forecast accuracies, to improve your out-of-stock prediction accuracies, and you're set. But it definitely reduces your entire time by literally 50%.
Any other questions? Okay, I think we'll wrap it up.
Cool. All right.
Do you want to give them your GitHub or any your link, your information how to contact you?
The entire solution is available on the Azure Databricks website, along with all of the notebooks, the data prep notebooks, the demand forecasting algorithms. All of them are available on the Databricks website. This is a certified solution that's up on the Databricks website. Yeah, so you could go refer it as well.
Thank you.
Cool. Thanks everyone.